why didn't the music work? What was that? I thought I had some issue with like the music not playing on my screens, but did it not play on stream either? Huh, weird. Okay. Well, welcome everyone. Today we're going to do an upgrade of the Snapmaker A250. So the A250 has been sitting idle for a while. It's always been like in the background somewhere in the studio. That's Domenico, you gotta work on your German, man. It's always been sitting in the studio somewhere unused for kind of like two reasons. First of all, I'm scared of the laser. That's still something I need to work out. The CNC, kind of weak, but also it was extremely annoying to use because it is so incredibly loud. So even with noise reduction, let me just turn it on and give you a sort of a before. That's just the power supply, by the way. Give you kind of a before overview. So that's the power supply. Of course, the screen, one of the big features, runs Android, which really doesn't matter at all. But it's a nice touchscreen once it boots up. Once we get a print running, I just kind of want to get it into the start motions and maybe just show you or let you experience how loud all the X's are. Because those two things are actually what the T upgrade is going to supposedly fix the most. So let's see what we have here. So there is our 5-inch Android tablet. Let's do start, USB, Samsung space. Oh, I printed that on Snapmaker. Okay. So yeah, you probably can hear that. That is annoyingly loud. It's like, hey, is it 2012 again? It's also not very. Ooh. That's milling stuff. Okay. Yeah. So supposedly the upgrade is going to fix that, and I'm excited to see if it will. Okay, I'm going to stop this, and we're going to tear it down. This action cannot be undone. Oh yeah, command buffer. So, yeah. Currently this is the A250 no T. So just off. Oh, nice. This is the A250. They sent it to me after the long delays and whatever. And once they got to sending it out, they had basically announced the T version. So kind of unfortunate that it was so late, and a machine that's already outdated, obviously I'm not going to be too interested in. So a quick overview on the A250. I do have the enclosure, which has pretty big gaps. So I wouldn't say that enclosure is safe. I mean, you can like look straight into the build envelope right there. 3D printing, yeah, I guess that's what it's going to be used mostly for. A laser engraving and cutting. It does have the 1.6 watt laser head. There we go, which is class 4. I mean, everything that can shoot your eye is class 4. It does have a camera built in. That big thing, that's the laser, and it does have an LED and a camera. I guess for like auto alignment, auto calibration. Yeah, it did do that, right. It did try to do the auto calibration, like laser head distance to your workpiece, where it kind of scores a line and then looks at that line with the camera, how wide it is. I don't think that worked too well in the stream. But that's that, and then of course you've got the milling. This one's quite heavy. The milling spindle, this is 50 watts, 6,000 to 12,000 RPM with an ER11 collet. We use that with acrylic, I think. With acrylic it worked really well, but in aluminum the bit immediately snapped off. I also didn't have any 1/8 inch end mills to test it with at the time. I do have some now, so we'll see how far we get. So yeah, laser engraving, you do get that heatsink table, and then CNC carving. They do show carbon fiber, which is like incredibly messy to mill. Also kind of dangerous if you breathe the dust, but that's a different story. Yeah, multi-material. I also do have the rotary axis, which they show somewhere. Various add-ons. I think it's somewhere right at the top. Bundle, 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 bundle. Where are you? There you are. That is the rotary axis that I've also got in the box still, which to me feels like very much of an overkill design to add to a machine that is like barely capable of CNCing, but I'm going to try that out eventually. I still do have that, and I do want to try that out. So yeah, upgrade to the Snapmaker T, mostly for sound. It's going to keep the modular design with everything being plugged in with these proprietary connectors. Apparently these run CAN bus, the website just told me. So yeah, now dual extrusion as well. Wait, but that is the, oh yeah, that's the big Artisan. Yeah, this is functionally going to stay the same machine. But I guess it's going to be better. It's going to be like worth reviewing because so far I just felt like it's making so many trade-offs, especially once you turn it on and it sounds like it's an ancient machine. That it's kind of, yeah, difficult. Nice to meet you. So these are the T upgrade parts. The Artisan, though, I think is not like a competitor to this. It's a totally different product. It's like the Prusa XL is not a replacement for the Mark IV, Mark III. So yeah, I hope this is going to stay relevant. I don't know. We will see. So Snapmaker 2.0 power module, it says. Yeah, I keep mixing up these buttons. Snapmaker 2.0 power module. Contact us if you need help. Does this have an address label? It does not, I think. So today I think we're actually going to be replacing most of the machine. There's not going to be much left of the original unit. We are going to... I just took that thing out of a box. Why is there another box? Okay, this was also packaged in another box, by the way. It looks exactly like the old one. I don't know what I expected. So, there. That's gonna be hard not to mix up. Because it like literally, you cannot tell them apart. They've got the same grill in the front with, like, this one has the LEDs. I don't think if this one still has the pulsating LEDs. Looks like it's got the same mounts on the inside, same back side. This one though, that's a neat detail, which I don't know if the camera's gonna pick up. Maybe this one. Sorry if that was loud for you all. Maybe that camera is going to pick that up. Yeah. Do you notice the difference with these fans? There is a, where is it there? There's a yellow wire in this fan, and this one does not have a yellow wire. Yellow is either a PWM or a TAC signal. So this one should at least have some sort of RPM sense, yeah, like Dominic is saying, which I guess explains how they managed to make it quiet. They're just running it slower. So that is the new one. Otherwise, yeah, weighs the same, feels the same. Maybe we can take this one apart once we got this one running. So that's the old parts. Where do I put those? I guess, yeah, we're gonna have a couple old parts once we're done. Power supply looks absolutely identical. Let's just plug it in and see if there is a difference immediately. Ooh, so it is on. It does have the glow. It's still pulsating. But if I hold it right up to my microphone, yeah, the fan is spinning. Just turn it off again. I can still hear it spin. I can still hear it spin? Yeah, it's still glowing. There we go. So when you turn it on, maybe that came through in the mic, but it ramps up the fan just a bit and then immediately spins down. So that fan is a lot quieter, even if there might be, once it's under load, once it's actually producing some heat. That has some pretty big caps in it. This is wireless. Once it's heated up, it's probably going to run at a bit higher RPM, but that is a lot better. So this is the actual main event, I guess. Does it say anything? It doesn't say. Yeah, it does say linear module, Snapmaker 2.0 A250 bundle. So that would suggest A250 bundle. Doesn't say anything about the T, so I hope these are actually the new ones. But I guess that's just transitional for packaging, that like everything's going to be T modules, even if the labeling says. Oh yeah, so I guess that kind of confirms that it's actually an upgrade, because it said, hey, remove the old modules, install the new modules. For detailed instructions on installing the new linear modules, see the quick start guide and upgrade the firmware. Okay, it comes with a new firmware. Does that? Well, okay. So I don't know if these actually have. Let me check the wiring. X, Y, Z. Yeah, no, these must have the stepper driver in the central module and not in the linear module itself, because otherwise they wouldn't need 8 pins. But it does have a pair of thicker pins, so I don't exactly know what's going on there. It's an upgrade kit for converting printers to Noctua fans that would include the buck adapters and all the fans needed, or even just a package of maybe 4 Noctua fans. For the Snapmaker, I don't think so. So this is, this is the upgrade kit that they sent out. I don't know if this is actually like an official thing they're selling. Get out! Wow, that's two more than I expected. Let me just double check that this is actually something you can buy. So, well, actually, parts, accessories for Snapmaker 2.0. Oh yeah, there is a 10-watt high-power laser module. I thought this was going to be included in this kit, but it's not, and I'm still stuck with the 1.6-watt one. But they do have a 10-watt laser module, but I believe for the 250T, A250T, this is an optional upgrade. CAN hub, 3D printing module, yeah, linear module for Snapmaker 2.0. Okay, so you just buy the, a new pack of linear motors, TMC 2209. Right, the drivers are in the modules, the drivers are in the linear rails, because otherwise it wouldn't make sense to upgrade those and they would be quieter. So screw rod leads, lead screw rods, screw rod leads, lead screws optimized, I guess. Easy attachment to other modules, well, the old ones did that as well. 2-year warranty, cool. Quite like never before, optimized screw rod leads. And yeah, it still has the same construction, still has the, well, they didn't ship one of those. Still has like the cover for the linear ways, all the mounting points, that is still there. So that is the linear rail kit. I don't want and what was the other one? The power supply. Yeah, power module. 129, quite a cooling fan. Yep, and automatic fan speed adjustment. I don't know if that's like, well, softer light. Look, these 3 upgrades, it's basically, hey, you add a resistor to the fan lead. if that's all it is, that's a 20-cent part. If you get a power resistor even. And softer light, like, I mean, if you don't care about the light, you just unplug it. We're gonna take the old one apart and we're gonna see like what makes it tick. But $129 upgrade or €129 upgrade, that is, no, I don't want your free PLA. It's not free. I'm selling my data for 500 grams of PLA. I don't think that's worth it. Yeah, so today's upgrade is, like, what was that? $349? The 250. How much is it for the 250? Yeah, no, 650. €650 plus the 129, so that's 780 euros. Let me just double check. Kitana, where did that come from? How much is that? $7.99. No, $8.49 after the price increase. So yeah, it's either you buy one of these or you buy the no audio, they say. Did my camera shut off? Oh yeah, my camera shut off again from over temperature. I'm just gonna put this fan up to it as I always do. And maybe has an even better idea. Let's turn down the AC one click. Sorry about the technical issues. There we go. Okay. Yeah. Where was I? Sorry about that. Yeah, a camera overheated. The Sony does not like summertime temperatures. I'm used to using it in the basement where it's like 18 degrees. Now it's 25 in the studio. So yeah, camera is not happy. Water cooling on the camera. Nah. Maybe so that's a different story that we can get into once we've got some time to chat. But now let's try and get these unboxed. So yeah, I was saying like 780 euros for the upgrade. And these are labeled on here as well. 780 euros for the upgrade. You do that, or you grab yourself almost another Prusa Mark III. So, yeah. But yeah, thanks everyone for letting me know I was having some struggles there with tech. But yeah, what I was mentioning from my finger pointing, I don't know who actually caught that. The way they are labeled with just being, linear module, lead 20, stroke 264 millimeters. This almost sounds to me like they're kind of like seeing these as building blocks where you buy a set of like linear rails and you use them for whatever. After all, they are just CAN-controlled little things, though I don't know what all these pins are for. Maybe if somebody knows if they publish a pinout and some sort of reference for how these are controlled. I mean, I guess the big boys are power plus minus. End stop maybe on some of these, but then you have CAN high, CAN low, and then there's still 2 pins left over. Yeah, maybe if somebody knows what the pinout is on these, then maybe I can use the old ones for something. Wonder if you can use the A250 modules on Z for extra height. I think they should fit like mechanically, but I don't think the firmware would be able to make any use of it. Also, nice touch that the X, and Y axes are like all offset to one side with the carriage, and the 2 Z axis modules are set up at a different position. That makes it really easy to tell them apart when you're assembling. I believe that is intentional. I don't think there would be a reason to like precisely align this, because these are all aligned with the carriage in the same position, almost the same position for the 2 that are different and the 3 that are the same. So that honestly, that's a nice touch. That is good thinking. All right, so it should actually just be a plug and play upgrade, right? So literally plug and play. Let's get these rubber bands off. The power supply still is not integrated into the printer. It's still just a box that's separate. What are you little hicks? Okay. So I wish they would somehow manage to at least attach it to the frame, but I guess that's not a high priority for them. All right, so I guess it's down to taking this thing apart. I saw on the website somewhere the packaging weight of, I think the A250, or was it the 350, I don't know, was 49 kilograms, which I believe that is very accurate. This is not a lightweight printer at all. Filament comes off, and then, I mean, it's just one size screw, right? So the, let's see. Toolhead. Toolhead is just attached to the X-axis with 4 screws. The X-axis is attached to the Z-axis, which makes sense. The Z-axis has, what are you? You are some sort of bracket. I don't remember what that bracket was for. But this bracket back here, I don't know what that was. That was something. That's there, and then these are attached to the bottom with just, I think they're screwed through the bottom. Yes, there's 4 screws down here, and then these little stiffener braces in the back. I guess we just rip everything off, and you guys can guide me through how to assemble it again. It's basically the exact same thing as assembling a new printer, but yeah. We're going to replace some of the parts. So what was that, 3 mil? Nope, 2.5. The bracket on the cable guide? Which bracket on the cable guide? What cable guide? Oh, you mean this guy's cable guide? Oh, that makes sense. That makes sense. Derek's asking, can you run this machine inside a nuclear reactor? I could try. The next one is like 10 kilometers away from here. Could just walk in and see if they let me just, just plop it in there and see if it keeps working. It's kind of a result of being made from basically identical parts. I mean, yeah, the Z-axis rails are different, and I think that that answers the question from Harry. Why are two different? These two have a lower pitch lead screw for the Z-axis, and the X and the two Y-axes are the same. And these two are different. That's the reason there. Cool. Pull, 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 pull. Huh, Paul found some pinouts for these. That is not, that's the heated bed. That has a very simple pinout. That is literally just power and thermistor. That should be easy to figure out. But these, I guess it's going to be interesting which side is top, but 24 volt direction, can low, NSEN, whatever NSEN is, step, can high, and ground. So it's got, what is, so what are they actually using CAN for? Because if you have step direction, you can run the axis, and then you just need an extra pin for fault or for an in-stop or something. That's interesting that they're still running CAN to the module, but the 2209 doesn't speak CAN, does it? So they must have some sort of CAN translator in that thing. If they're actually talking to the, oh, not connected. Okay, that makes sense. They must have a full CAN-capable chip in there just for running an in-stop. That seems wasteful. Huh. All parts for camera robot? Yeah, if I can run them. If they run without the CAN, then it should make for a nice integrated linear axis. In fact, I'm gonna attach this master module controller thing to the new Z-axis bracket, or Z-axis axis, just to make sure we keep it in roughly like the same spot. It was there. Nope, it was there. Come on, come on. Go. So just to make sure we don't lose track of this thing, and I guess we can also attach that little bracket that we took off, cable guide. So that's that. Now, having these two parts side by side, they really look identical, and I'm sure they're just making the same parts and they're putting different electronics in them, which makes sense. I mean, there's no reason to like redo everything. But it would be nice if higher. Oh God, I missed. Thanks, Harry. I guess it would be nice if it was really just a hardware upgrade where you replace one PCB inside and you pay like $20 for that PCB instead of paying $650. Because I don't think they would have changed the stepper motors unless they were really thorough and were like, hey, these motors actually work a lot better with the Trinamic drivers, which can happen. But I am not sure about that. You ask the CAN board to do the operation and let it handle itself. Well, does it do that though? I guess I'm gonna have to put a logic analyzer on these pins and just see what they do. Because I mean, if it is step direction enable, it doesn't necessarily mean that they're actually using that. You can perfectly well drive an axis through CAN. Wrapper Firmware, Do-It 3D is doing that with the Do-It 3. In fact, my Voron behind me, you can see it in frame there. I think I'm running the extruder axis on an expansion board, I think, yeah, well, I don't know. But yeah, And that is just connected through CAN. That does not have, oh yeah, that other bit. That does not have a step direction signal attached to it at all. Where was that? Was that here? I guess. So yeah, camera robot. I did briefly talk about this on the Meltzone podcast. I know I keep talking about this here too, but camera robot for the studio, for the B-cam, for the camera you're seeing right now. My goal would be to just being able to press a button and that camera like physically moves around and transitions to the top camera and transitions to the A camera and just physically moves there. That would be extremely sweet. Bit tough to build. I mean, I'm not gonna lie there. That's you know, just a tiny bit challenging. First challenge, high torque gearboxes, and then like you need the controls, which RepRap Firmware is slowly implementing. They're working on robot support. But yeah, it's not a small project. KUKA arm. The thing is, I don't want to die using it. That is maybe one thing I should have mentioned. I don't want the thing to crush me. So KUKA, at some point, there's actually a company next door that uses tons of those, but yeah, like I said, probably not the right tool for the job. I want something that's, nope. I want something that's a bit less deadly. So yeah, that. So one day, Elephant Robotics reached out. You know, whatever, they're a Chinese company, they make robot arms, quote unquote robot arms. And they were like, hey, we saw you have a channel and you're doing like 3D stuff. Could you like use a robot arm? And looked through their stuff and I was like, well, if you have something that can that can handle a camera, you know, handle the 3D printing extruder, and you know, maybe we can work something out. They were like, sure, we can send you our 320 model, which has like a 5 kilogram payload and is 600 millimeter reach. And I was like, sure, that sounds great. Let's try it out. And then 2 days later, they were like, can we send you our 280 instead? And I looked at that. And I was like, no, that's literally 5 RC servos in a case. You watch videos about that. For example, from Scientific, fantastic YouTube channel, who tests that exact arm, and you can just see it wobbling around. It's just, it's literally like it moves. It's like it's this long. It's like not even usable. It moves, and it's like, and then you put some weight on it, and it drops by 5 centimeters. It's like you put a camera on it, you get seasick from it. So I was like, nah, I thought we were doing the 320. Don't you have a use for this one? I was like, no. But can't you like make a project about it? No. And now they wrote me again. They want to send me another one that has 2 of those arms, 2 of those RC servo crappy unusable arms. I mean, it's fine if you do like robot workshops and you have kids around them. That's totally cool for that, because you know you're not going to be lifting heavy stuff. You don't need like super high precision, but you know, if they want me to feature one of their robot arms, I'm not going to feature one that I can't use. So yeah, that's the story of Elephant Robotics and their influencer bait and switch. Best of all, for those 5 or 6 RC servos plus a Raspberry Pi, they charge $700. That's like a 7x markup. So yeah. And if you buy a capable robot arm for this sort of stuff, if you buy a cobots are those that have sensing in the axes or are weak enough to not break your arm, like 2,000 to 5,000 euros roughly. Sometimes they come with a controller, sometimes they don't. So yeah, it's not a cheap endeavor if I were to buy one. So I was looking into like 3D printing cycloidal gearboxes, which always makes for pretty thumbnails and for pretty videos. And then maybe if that works out, we can work our way up and move into like a proper robot arm assembly that step by step takes us to something that's usable. I don't know. It's a big project. Other kinematics though, I'm just gonna call it fennel. Other kinematics, so yeah, I do have some space here in the studio. The problem is if you want to attach anything to the ceiling, that is my wooden truss system that has like all sorts of stuff attached to it. So you'd have to have whatever wires you have go through that. And also it's going to be pretty long. That's like 5 meters up. So I don't know if that's the best approach there. By the way, I'm going to need the manual because these screws have 2 different lengths. These are 8 or 10s. These are 2 millimeters longer. Oh God, that's tight. Who tightened these? Ah, okay. So yeah, I'm going to have to figure something out with like robots. Maybe I'm going to have someone working with me for content and for a project like that. We're going to see. Maybe that's going to work out. And if that works out, I can crank up the content. I can take on those larger projects. Kind of like tech writer style. Like what would Linus do? Linus would hire more people. That seems to be the pretty universal answer. Buckstein Becker, do you have some plans for the rest of the year? Any reviews in the pipeline? So reviews are just of some stuff that shows up. I've been declining a lot of printers. I've been declining a lot of products. I get something every day where it's like, hey, you want to test out our new laser? And it's like some frameless laser cutter that I've always said no to because I do value my eyesight. And then Creality reached out for a new Ender 3, and I'm still on the fence about that. Yeah, I mean, if there's exciting stuff, if there's stuff that's like really different and new, maybe you guys have some suggestions. But yeah, like full product reviews, I don't know. There's some of the worst performing videos on the channel, and I don't know if I want to keep making worst performing videos. So like, I do have. Oh, I don't have these here, but yeah, E3D did send me some Obsidians, which are not going to be out for a while, and they're like, hey, feel free to tease them. You guys have been teasing them for a year. Like, I'm not going to be teasing them any more than that. So the idea with Obsidian for me is I'm not going to have a full review because we know it's going to print, right? We know they're not going to put a product out there that's not going to do that core function that it's built to do. I'm going to test how tough they are. I'm going to intentionally destroy them and see how far, well, one of them. I'm going to keep the 0.6. I'm going to destroy the 0.4 because that is the less useful one of those, out of those two. So I'm going to destroy an Obsidian, and I'll compare it against, regular hardened nozzle, against brass, against some slice engineering nozzles. I do have a ruby nozzles. I could throw those in as well. Ha! Yeah, and hopefully that's going to answer the question once and for all, like, was it worth the wait? Because that is... that is the one thing that V3D have been advertising it for, being like the end-all nozzle, the only nozzle you will ever need. So I'll test that. I'll see how much they can take before they fail, and they will fail. Trust me, the Obsidian will be destroyed by the end of that video. So that's kind of the approach. Like, see what the story is, and not just have a, hey, this product is good, this product is bad in this regard. People just don't care about that plain stuff, that plain content anymore, right? Who was talking about concrete and stuff being bolted down? Big, strong, moving arm without torque sensor, if not set up properly, can nope you off the planet. Yep. Robot arms wouldn't be the first time they crush someone. Usually, if you have a regular, I'm going to call it a regular robot arm, like not a cobot that has torque sensors, as in torque sensors that stop when they sense they are running into something. They have like in the range of hundreds of Newton meters of torque at times, which is, you know, especially if you're like in the joint, like in an elbow here, if you put your arm in here and the robot pinches down on that, your arm is gone. Not just your arm, but potentially like your upper body, upper half of your body is like severed in half. They can very quickly, very unspectacularly completely maim you. So, you know, they're fun to play with in a safe way. So usually once, you know, when they're set up professionally, they're either fully enclosed, so like in a completely separate room, or if they are like in a semi-open environment where we have to get to them essentially, they often have like a laser curtain in front of them, like not like an emancipation grid, but laser curtain that shuts off the robot or puts it into a super low speed mode once it senses somebody going in there. So that kind of makes it impractical to use it out in the open. It makes it safe to use in an industrial professional environment. But yeah, you wouldn't want to run it at those super slow crawl speeds, at that safe speed essentially. And for 3D printing and for camera moves, I mean, camera moves, they don't need to be super fast, but I think they need to be faster than what crawl speed is. So yeah, what I would build would have like a 500 gram payload, maybe at most. That is very, very magnetic. 500 gram payload, which means yes, it could probably crush a cucumber, but it would be relatively safe to use. We'll see. Derek's asking, could I entice you to make a filament extruder that supported making carbon-filled PLA and PETG beyond rallying people to get funds? What else would you need? A filament extruder that could make carbon fiber, PETG, and PLA. Is that loose? Yeah. What would I need? I mean, it's really just time. It's perspective maybe is nicer. There we go. There. Get out of here. It's really just time. I think I could make an extruder. The thing is just, would it be something that I can turn into a video? Because my main business is still videos, right? It is making content that I upload on YouTube. If I were to then sell that extruder and turn it into a product, I mean, yeah, I guess, but that's even more work than making a single video about it. I kind of know what it takes to make a filament extruder. I've built one before. It was not very good. It's either you really overbuild it, which is like what industrial filament extruders typically are built like, with just huge, massive parts, or you apply I didn't even have to remove that. Crap. Well, I guess this is just bolted down from the bottom. Either you overbuild it like crazy, or you apply some really smart. That's why these are bolted down. You apply some really smart control algorithms to it and tune it, and you know, you'd be able to build it a bit more lightweight. But the thing is, the difference between a extruder that's capable of extruding already said it, of extruding carbon fiber filled stuff. It's like you need something that can compound those properly. So like some mixing stage, maybe in the extruder itself, maybe as like a previous step. And there are compounding extruders that do that. Basically, they mix together whatever additives, fillers, stuff you want in your material. They extrude it into pellets again. They get chopped and immediately get cooled down. And then you take those pre-compounded pellets and turn it into filament or into whatever injection molded part you want. So you would need that extra stage, and possibly for wear resistance, you would need hardened components. So the main screw, the nozzles, all the parts that basically rotate and move would need to be fully hardened, which makes them a bit more expensive and a bit trickier to machine, but it's not something that's particularly challenging. It's just, more work and more cost. Oh yeah, that's because the other side is still bolted down. Okay. Oh, I could take that off. No, I'm just going to leave it bolted down. So I don't know if that is a particularly interesting topic, though. Yeah, Paul, I've seen the video from MKBHD about his camera robot. Yeah, like we're really gonna need to bump up the Patreon earnings for me to be able to afford one of those and to justify one of those to be exact. I mean, that's a really sweet setup, but how much is that gonna be? 150K? Maybe more? I don't know. Like that's a different level for sure. Okay, and at this point, we don't really have much printer left. Like this is what we're keeping. We're keeping the base. It's all about that base, though. Come on. So yeah, this is what we're keeping. And the tool heads, and the screen, and the main board. But most of the printer we're chucking, which is why I'm saying it seems kind of wasteful, but that's how it is. Where were those longer screws? That's one of the longer ones. And the rest is all M4x8. Why is there one longer screw? Was that from this guy? Oh yeah, it must have been. It must have been from here. And then there's got to be a second one, which probably I've already screwed in somewhere, and we're not going to find again. Okay, but I've got more of these. It's probably in the bracket. Probably in this bracket. Let me see if this was one of the longer ones. That's a rebuild, not a fix-up. Yeah, it's not an upgrade. Personally, I would agree that there's going to be more improvement in... Ah, that's the long one. Oh, no, let's actually keep it with this one. There's going to be a lot more improvement in software, as we've seen with Arachne. I mean, that was purely a software upgrade. And it opened up a whole bunch of new possibilities. Okay, last 4 screws. So we are keeping the base frame of the bed, but we are getting rid of these 2 Y-axis motion units. And I think that is what I'm gonna That's what I'm going to start with. What's it saying? Reassembly is the reversal of disassembly. A boom arm like what even Miranda has. The boom, so the concept of having like a boom arm is you get vertical movement. Basically, you get vertical and like rotational movement, but you don't get translational movement for the most part. So if I wanted a camera to move from there to here, that wouldn't do it because it has to move forward as well. So maybe if you add like a y-axis, I guess, to a boom arm like that, that could work. But then you've got the issue of, hey, how do I counterbalance that? Because now you have a dynamic center of gravity for your payload. It's like, that does get more tricky than you imagine. This is something like Chappelle's one. Does even have a different one? Dominica, your mod, you can post a link to Ivan's arm, and we can have a look at it. Ivan's is more of a standard jib arm. Yeah, that's what I'm thinking, right? So you have like the two parallel arms that kind of move like this, and they keep your camera pointing forward. So kind of like that. And that's your standard jib, which you can DIY pretty easily. Helge's asking, hey, is this machine finally quiet? It is, I mean, yeah, it is very quiet right now. I'll give you that much. This is right now the quietest of 3D printers that I've ever used. We will see how quiet it is once it's reassembled, because that still needs to be determined. But yeah, this is all the previous parts out. 5 of the linear actors. And these don't have the nice engraving and labeling on them. Look at that. These new ones, they have the Snapmaker linear module and kind of the specs with the 20mm lead and 264mm stroke on them. The old ones don't. The old ones are just plain, but otherwise they are. I'm also holding it backwards, but otherwise they are pretty much identical. It's all the same materials, finish. These come out of the same molds. I mean, they're meant to be compatible, right? That's the entire goal. But yeah, probably mostly the same parts. So this thing is symmetrical, so it doesn't really matter, right? These were like that. I guess we can do, yeah, cables to the left. This goes on here, and then this also goes on here. That's going to be the 2 y-axis slides, the 2 y-axis linear modules. And I think I'm not supposed to bolt these down, if I remember from the assembly. I'm not supposed to bolt these down 100%, because these still need to rotate and get aligned in the base frame, though. Yeah, these screws are kind of hard to get to. There was... Oh yeah, no, there's holes in the base frame to get to these. So I'm just going to loosely assemble these. I'm not going to screw these down all the way yet, just because getting the screws in is going to be really tough in the end. But yeah, as long as I don't tighten these down, like maybe a bit less than that even, this should be fine. Monkey Butler, yeah, so the parts that are changing are, we get a new power supply, and at the beginning I did turn that on. It now has a fan that spins down. The old one was extremely noisy. And we get 5 new linear axes assemblies that now use Trinamic drivers and are a lot quieter. It's also a €780 upgrade, so yeah, tough one. Let's have a quick look at the... Oh. How does that link node work? Copy link address. Let's have a quick look at the video from Ivan. Why is that studio.youtube.com? What's up with that? Is that... Ah, okay, but it doesn't have... Hold on, I'm just going to set up the screen capture real quick. You're going to see the nice... Whoop. That effect. So that is what Ivan is doing.
Hey everyone, I don't...
Nope. So he has the features. He doesn't have any translational in and out, right? Yeah, he does have the he does have some pan, and he does have manual tilt. Yeah, that's the motion you kind of can get. You can see it keeps pointing in the forward direction, but you can only ever move. You can only move the camera along a ball surface around the center point. So basically, you're in the middle, and you can point the camera whichever direction you want. You can probably position this as well, but it's always going to be a fixed distance from your, sorry if that was loud, from your center position away. So for me for my setup here to work with that sort of mechanism, I guess I would need to have the center point like here, because this is what's happening, this is what's going on. So I would need some sort of pivot right here and have the camera point backwards. Basically need the inverse of what Ivan is building. So unless we can figure out like some crazy way to do the kinematics for that, I don't think it would be very practical for me here. And Paul pulled a classic, turned off a smart plug that was connected to a printer. Well, I shouldn't laugh. I shouldn't laugh. That's painful. I'm sorry, Paul. But I can feel your pain. I've got like, how many do I have now? 10 smart plugs all over the house. Not for printer control, which is a nice feature as well. If you want an emergency stop that can take the printer completely offline, that's good. And I think there are Octoprint plugins for that. But I do use them for solar power control to make sure that all the solar power I'm generating throughout the day, typically these days it's like 120 kilowatt hours, gets used as efficiently around the house as possible. So that turns on and off EV chargers, it turns on and off hot water heaters, dehumidifiers in the basement. What else am I controlling? Yeah, that's basically it. I'm controlling some other stuff too. I forgot, but yeah, stuff that can run whenever basically, that gets controlled through my management system, and it's all based on regular smart plugs. $10, get some Tasmota pre-flashed ones. It's pretty great. Okay. Let me just concentrate here for a second. So these are the holes that are going to be used to tighten down these screws that attach our Y-axis plates to the carriages on each one. Which means this actually goes on like that. Like that. And then we just align this. And I think I should put this on a box. We're just going to align this to the holes, and that should be all we need to do. What are you? You are PTG Clear. Classic. Kind of bland though. Plus, so somebody explained this to me. Prushiment has the tolerances on there. Maybe this camera's better for that. Prushiment has the tolerances on it. And PETG, the PETG they're making, I don't know if it is still this good. This is from 2020. It's like dead nuts. This is so dead on with the tolerances. And it is PETG specifically that is extremely good from Prushiment. How do they do that? And maybe kind of to expand on that, how am I supposed to replicate that with a DIY extruder? Because they have a lot more time and research into this than I possibly ever could. So yeah, DIY filament extruders, it would need to be not competitive, but at least very usable and very tight in tolerances, because filaments can do that these days. And if I'm going to build something, I want to at least be on par. Okay, so these just get bolted down, and I think there's a bit of an alignment groove, but it's on both sides. So if I feel down here, can you see that from there? Yeah, but there's a groove that goes on both sides of these, so I don't have to worry about pushing it over to one side or not. These just get held in place by bolting them down. Something about the viscosity? Possibly. 120 kilowatts a day? Well, it's 120 kilowatts is a bad summer day. Kilowatt hours to be accurate. I don't want to mix up those units. I think the record was 185 kilowatt hours on like June 14th last year, where it was reasonably warm and very sunny, which is, it's a nice figure. And it's an east-west system, and if you had the same 30 kilowatt. Ooh, new Prushiment nylon. That's interesting. So to close out the solar power thing, Monkey Butler Labs is asking, what's the payback window on solar of that size? Well, it depends on what you pay for it, as always. The simulation said it was going to be around 7 years for mine, with like how much I'm getting paid for feed in and how much power or electricity buy from the grid cost. With EVs and me moving to like air conditioning that I use as heat pumps in the winter, and I'm basically making the most use out of the power that I have, out of the electricity I have, it is a lot quicker than that. It's probably more than 5 or more like 5 years, 4 to 5 years, if you really optimize your consumption, which I am doing. I am probably over optimizing. But yeah, that's like the rough ballpark. It definitely pays to put up some solar. Yeah, Paul, it's more than 2 full charges for a big EV. It's just the chargers aren't that fast. I've actually limited mine. Probably shouldn't say that too loud because the incentives were for 11 kilowatts, not more and not less. But I've limited mine to single phase, and I've split them over the phases, so it's fine. To use less power, because that makes it easier to control, and I don't need to pump the car full with electricity just at those times during the day when there's more than 11 kilowatts. I want to like slowly trickle charge it, and even in winter I want to be able to charge it without buying back from the grid. So it's better for the grid too if you slowly charge and don't have like on off 11 kilowatts all the time. So yeah, it does fill up EVs pretty well though, so never had an issue of not having a charge car, which is very nice. Tustin, AC as a heat pump. Well, the regular mini split units, they all are inverter units. They have the heat pump switchover valve. Perfectly fine. They have decent efficiencies. It's not, I mean, it's literally the push of a button. You don't have to mod anything. It's not like window AC units that you have in the US, like proper efficient ones, I mean. Okay, Domenico, see you in a bit. Paul, no way to limit EV charge current in the EV's app. No, we have a Renault Zoe and mine is a Peugeot E208 and neither one has the option to limit current. Not in the app, not in the car. In fact, nowhere. The only features they have is delayed charge start through the app, and I think with the Zoe you can do it through the API as well. But then you can't stop the charge. Like it's gonna charge until it's full. It's never gonna stop again, which kind of sucks too, because you know it's gonna start charging midday at noon, where it's like, hey, I've got enough power now. And then at night at 6 p.m. the sun goes down. And it's like, I still have enough power. I'm still gonna charge at 11 kilowatts, and you're buying all the power from the grid. So yeah, that's not an option. What I'm doing with my wall box, with my EV charging equipment, is I'm just triggering I think it's the control pin, which is the pin made to do exactly that. I'm just switching that on and off with a Shelly. Literally just the Shelly, the little pucks. They have a single relay. They get powered off at 230 volts. They just switch the CP on and off, and that works absolutely beautiful. The EV is happy, the wall box is happy, all good. It's literally just sitting in between the wall box and the car. And it's like an on-off switch for the charge process. Some nice updates in the future. Yeah, Paul, forget about that. Peugeot's not going to update anything. At least they're not going to add features. So, let's get these plugged in. We have the splitter for the Y-axis. I guess we can choose whichever one, but one of these is labeled. So that's Z, that's Y. So both of these get connected into this splitter box. Where did this go? Down here or around the back? I guess it would be cleaner if you go... It doesn't matter. Wire management on this printer is a mess anyway. It's not like some other printers that have like nice drag chains and stuff to sort these. This is just like, hey, we have some cables. I guess let's do that then. This goes through here, then that goes through there. Then I guess I can push these back gently. Which one was Y? This one was Y. And the 1 and the 2. And since these are identical, it doesn't matter which way around I connect these. So that's that. Trust me, yeah, the dashboard video still is, to this date, my best performing video on the entire channel, which is funny every time I bring it up because it has nothing to do with 3D printing. You know, I'm running a 3D printing channel, mostly 3D printing channel, and the one video where I outdo myself uses like 4 3D printed brackets, and that's it. So it's just kind of odd, because it means I can't easily reproduce that. And the project videos that I've done in the past with like the battery builder stuff, they've been absolute, you know, what's the word? Duds. They have not performed well at all. So the effort I put into those projects very often just isn't worth it. With the dashboard build, yeah, that was building a frame, like building a wooden frame. That was the biggest thing, and then yeah, you add some software features to it. But it's just very hit and miss. And with 3D printing content, at least I know that, you know, some people are going to care about it. So it just makes it hard to justify non-3D printing project videos for me, to put the time into those. Yeah, and also about your oil heater, we did that. The biggest, so we had an oil heater in the house up until like 8 years ago. And we had 6,000 liters worth of oil in plastic tanks in the basement. Did I grab the correct axis? Yes, I did. And the thing was that you don't realize is how much the house reeks of oil, of heating oil, which, I mean, these days is basically diesel with some colorant, so you don't do tax evasion with it. But yeah, the house, like, as soon as you open up the front door, you'd get that unverwechselbare, the unmistakable smell of oil, of heating oil. And you don't smell it after a while. You get used to it. And you walk in and it's like finding somebody else walks in and they're like, what the hell happened to your house? Once we got rid of that, pretty cool. Pretty cool. We actually gained an extra room, which I used as a printer room for a while. And we put in a gas heater, which, looking back, was a bit of a mistake. Would have put in a heat pump, but yeah, that's what we did at the time. So now we're looking at replacing that with an actual heat pump. Thing is, incentives just changed for Germany, so like that's a bit of a chaos. But yeah, that's going to happen. I would not, especially in this day and age, I would not put in any sort of gas heating. And I think, and we did pay quite a bit of money to get the gas connection to the house. Definitely full waste of cash. But hey, you always learn, live and learn. You're always smarter in the end. So that is the Z-axis attached. Now it is the X-axis. So I don't have, let me get that straight. I don't have the Z-axis attached rigidly yet because I first want to get the X-axis bolted in. And if I attach these like slightly crooked, I'm not going to be able to bolt these in. So actually, I'm just going to leave it like that. And the controller is going to be on this side. That's the controller box, so the cable should come out this way. Do we want to get into the pellets discussion? I guess just briefly, pellets are... I just got to get this in the right hole real quick. Pellets are not the way to go. Wood burning isn't great. There's a limited amount of wood supply available, and if you look at how much wood is regrowing every year, and like I did the numbers for Germany, it is somewhere in the neighborhood of like 1% of the amount of gas in energy that we're using. Out of all the like maximum amount of wood that we could extract from our forest. Is like 1% of the energy that we're using in gas. So it is definitely not sustainable to burn wood. Wood is better left in the forest where it can grow, where it can be a tree, and it is too valuable to fire up. Plus there's of course the entire thing with like fine particulates emissions, and that's something you're not gonna get rid of particularly fast or particularly efficiently. And if you add filtration to all those systems, like it's going to get ridiculously expensive. It's just, yeah. And also it is very much, as Thomas is pointing out, it's not just tied to the price of gas. It's also something that the more people use wood or burn wood for energy and for heat, the more price is going to go up because supply is, like I said, it is limited. The amount of wood that is regrowing every year, it's finite. It is a finite amount of resources we have there. So honestly, only way to go, solar, both solar electricity, photovoltaics, and for heat collections, or for heat collection with like vacuum collectors and stuff. That is like one of the most profitable ways to collect electricity. So that's going to be what I'm going to be going for. Fill up the rest of the roof, whatever space is left, with vacuum collectors. Use that as heating support in the winter, and then do the rest with a heat pump and the solar photovoltaics that we have. That is honestly the only sustainable option. Okay, so that should make for some spicy comments under the video. Once this is up as a recording, which of course these streams always are. Where are we at? We have x-axis is bolted solidly to the z-axis. The z-axis is loosely bolted down, though honestly this is pretty rigid already. We still need the bolts from the bottom. The y-axis is tied down. And then we just plug everything in and it should work. I think I looked at the same thing during the initial stream, but I'm spreading screws all over the table. But you have this bracket. This front bracket, this is a different piece of extrusion. Maybe this isn't bent. This is too tight of a radius to be bent. That must be extrusion as well, I think. It's a different one from these. I think they could have just used like the same die to make this and that, and then just cut away like this rear brace for the phone mount or for the screen mount. Yeah. So we still need these. This is the z-axis. Oh, let me try that again. We still need these, which is the z-axis mounts these bolts to the bottom as well. They don't just bolt to the back, which I still need to tighten down, but we also need the ones from the bottom, which I think it should be fine without. This is already quite rigid, but the screws are there, so let's do that. Did I tighten down the bed? I did tighten these down through the bottom frame. Ow. Ow. It's like watching paint dry. It's watching Tom screw. So, for these, thankfully these are all the same size. So that does make it quite convenient. There are a couple of other screws, for example, these what are these called? Senkkopfschrauben, countersunk screws, which go in the bed, in the 3D printing bed, heated bed at least, and a couple longer ones for some parts, like the spool mount, which is just more beefy material that you have to screw through. But otherwise, it's all these M4 by 8, I think. So that's pretty good. It's a clickbait title. What title are you talking about? All right. So 4 more screws. Where do those go? That's for the that's for the tool head. Oh, watch Tom screw. Yeah, though YouTube probably doesn't like that sort of content. Not using your electric screwdriver anymore. So I do have the Bosch Go at hand. Ow! Ah! Just rammed my hand into the end of the hex driver. I do have the Bosch Go, but I've grown to dislike it. I was never like a huge fan of this. I was like, I guess it's fine because it does have the torque clutch, which I find is kind of important. But the fact that it has the dual activation where you push it, like you literally, I don't want to do that. That's going to put a hole in my hand. But as soon as you put pressure on the tip, it starts turning, and then you also have the button, which is like super, like it doesn't have any feedback at all. The fact that it doesn't have any RPM control, I think that's the bigger one. Like it immediately spins up to full RPM, and that just makes it sort of uncontrollable. So I found that I slip out of screw heads quite often. I mar up those screws, and it's a very unpleasant experience. I don't know what exactly it would be good for, but it is not good for working on 3D printers. I have learned that much. Okay, so I can tighten these now that everything is roughly in alignment. And with everything being machined parts and aluminum, there shouldn't be much of a misalignment happening. At the very least, it's going to be as good as most other 3D printers that really don't have any sort of way to compensate for alignment, like all the Ender 3s. The Z-axis, it's as good as, it's as square as those profiles are cut. So if those Z-axis profiles, like the cut down here where it meets the base, if that isn't cut square, well, your prints are going to be crooked. So yeah, at least these are all machined surfaces. It should be good enough. It should be within tolerance of what you can achieve with, you know, a 3D printing process in general. Okay, next up, plugging in the Z-axis. So, Z-axis is these two guys, 1 and 2, and they go into this multiplexer or splitter or whatever you want to call it. And same as with the Y-axis. There we go. Again, no cable management really. It's just the cables land wherever they land. And they're going to be mostly out of the way. And then, yeah, these go up to the control board. Okay, what time is it? It is 9 p.m. So I'm gonna do the same thing. Oh, I'm glad I didn't smash the screen with that. I'm gonna do the same thing I did at the start, and I'm just gonna start a 3D print. So this USB-C is very, very loose. Don't know if I noted that in the first couple of videos, but that's the screen. It's like very loose, but okay. It's a mini USB. So plugging stuff in. This isn't hard. Yeah, I did take off the original dust caps from X, Y, and Z. They also had dust caps, but like you're never going to be unplugging anything. You're never going to be leaving these open while you run the machine. You're always going to have an X, Y, and Z axis. So this is X. Then this is, what was that? Oh, these are labeled, right. These have the label on them. This is Y, and then this is Z. And that is it. Power heated bed and tool head. That's also something we're going to need to plug in and attach. So next up, heated bed. And this should still work. I mean, there's no reason why it wouldn't. The Snapmaker does detect which tool head you have attached to it, and it automatically changes its control scheme. It changes which G-codes it reads. Some of the G-codes are processed for 3D printing, for laser cutting, or for milling. And I think there's even the additional 4th axis milling add-on that it detects and displays only G-codes that were sliced with that in mind. So that's pretty good. But I think for that to work, you do need to have the correct tool head attached. So I will attach the correct tool head. And maybe if I have a 2.5, yeah, I do have a 2.5. Maybe we can just try the Bosch Go for these. Let's just see how well this goes. Since you guys were asking about it, that's a 2.5mm bit, which is apparently very magnetic. And then the Bosch, I'm going to have that on lowest torque. Let's do that actually. Yep. I mean, that isn't significantly faster than what I can do by hand. Up, and that tried to cross-thread it. I mean, look at this. If I go in here by hand and I tighten this one, that's pretty much the same speed. Plus, I now get a feel for whether I'm cross-threading or not. And I get a feel for how this thing bottoms out. Though the clutch is pretty good and pretty usable. And I don't think this should actually need more than the minimum torque this thing can clutch to. Okay. This is just me pressing down. There's no button pressing going on. Yeah. The thing is, on stream, of course, it does make a lot of noise. It is, I guess, annoying for you guys to listen to. I would assume. It is annoying for me to listen to. So, bed goes on. There's no positive stop as with the pusher beds where you have the two screws in the bed and you just slide it up against that. You always have to kind of align it, but it's good enough. So that needs to be plugged into the heated bed output, which is somewhere. Heated bed, it's this one. So yeah, there is no strain relief in these cables except for what the molded plug has built in, which really isn't. I mean, it's not strain relief. If we're totally honest here, these, you know, let's show on that cam. I think that's easier. Where is my? Yeah. These have a relatively hard plastic strain relief looking thing on them, but really, if you bend the cable, it's the cable that bends and not this relieved section right there. So the strain is still going to be on the cable. It doesn't really bend the other way. Like it doesn't want to bend this way, but it still flexes that way quite a bit, and that spot right there, that's where it's going to break. Yeah. What did I unplug? I unplugged the X-axis. And I mean, as you can see, this is a bit of a rat's nest just hanging off the back of the printer. It's not bad because it's all, you know, sleeves or molded. I don't know what this is called. It doesn't have individual wire strands in it. So that's good at least. So it's not going to get caught on much. But for example, the heated bed is already sliding on the axis here and bumping against that. So as that moves around, which is hard to move, yeah, it keeps dragging over that, and then this could be cleaner. It's not been an issue so far, but it could be cleaner. Bed is on. We're gonna need a tool head. We're gonna need the 3D printing tool head though. So that just goes on and on and on. Like that. And then the 4 last screws from the back. Oh yeah, and the spool mount. We're gonna need that as well. So this one always uses the 4 corner screws for the tool heads. And those exclusively, and none of the others. Or does it? No, it doesn't. It doesn't. It used the ones one down. Okay. Also, yeah, this what I'm doing right now, where I'm pushing the print around, where I'm pushing the screw in just to find the hole, just to find the thread in the other part. That is pretty hard to do with the Bosch Go because it's going to start turning, it's going to start making noise, it's going to start vibrating, and it's going to kick stuff around. So just that feel is what I'm missing with that screwdriver. Plus the bits are too short to actually reach all the way across there. There's like no space at all here. Okay. So how long did that take us, including futzing around? How long are we live for? 1.5 hours. So I guess you could do this in an hour. Swap out all the parts. And there shouldn't be any calibration needed because there is a probe on this tool head. So okay, I think right there, if I'm not mistaken, yeah, in the back here, that is some sort of a sensor. I believe it's inductive. And of course, the axes all have their own end stops, so there shouldn't be anything for you left to do except plug it together, start it up, start your prints, or whatever else you want to do with it. Of course, this does do more than 3D printing, but those features didn't really change. Like, this still is the same CNC, the same laser. It still has the same tool heads for that, the same 50-watt CNC and the 1.6-watt laser head. And whether those are useful for you or not, that's something that you're going to have to decide. They are on the very light-duty side, definitely. Come on. So I'm not going to install Luban for now. I don't think I have Luban, which is their slicer package, which does do CNC, 3D printing, laser cutting, G-code generation, all in one software. I don't have that installed on my streaming PC yet. But we do have some G-codes on here, so that should be all right. And I guess you're the tool head. Yep. That plugs in here, and that plugs into tool head. There we go. Power. Power is the last one. Where did we put the power cable? That's one that we're definitely going to need. Maybe let's try this one. Yep, that's the simple one. 2 pins and 2 small ones. I guess there's like a status information or something in there. Let's get you over here. Power. And then the power supply needs power. Let's see how quiet this is. And we're going to turn it on. Everything in frame. Yeah, okay, power supply is still quiet when it's connected to machine. That's good. Screen's still unreadable when it's like in full reflection mode. But we can do that. And we can start a print in a second once it's booted up. Maybe. Yeah, so one of the selling features, of course, is this runs Android. And I'm like, that's cool, but what is the benefits of this running Android? Because it just takes longer to boot. You don't get anything from this running a full Android distribution. You don't get to install apps. Oh, it does need a firmware update. Harry, thank you for reminding me. You don't get to run apps on this. You don't get to do like custom stuff. It just runs the firmware. That is it. So this is, I mean, it's not like an accident that this looks like a phone, because this essentially is a phone. But let's see what it actually says. If it runs without the firmware update at all. It runs. Hopefully in the right direction. Guess it has end stops up there. Yeah, that sounded like it clicked. It seems to work fine without the update. I guess like yeah, it does the thing. Oh, that's faster than before, I think. That went down pretty far. But that seems to work, and that was very quiet. It was very quiet. Yeah, except for the fan, there is a hot and cooling fan, I guess, in here. Yeah, it's not... No, power cooling's also got some airflow going. The hot and cooling definitely has a fan that runs. That is now the noisiest part, which often is the case for quiet machines that slap a dynamic driver on there and call it done. Let's see if it prints without the update, because so far it is looking good. 3D Pretty Iceland is here. Hey, good to see you around again. Who of you am I going to see at Earth? That's been an interesting one. Just the decision to go to Earth. That was a drawn out one for me. But yeah, I will be at Earth. First show since the onset of the pandemic. I think it's going to be fun. It's going to be stressful, yeah, but it's going to be fun for sure. Even more so if I get to see some familiar faces. That piece of filament's not going to last long. That's an excellent point, actually. Can you tell it's 9 p.m.? There, that should last a bit longer now. What's the printer saying? It is heating up the heated bed. It's 63 degrees. 3P Iceland has a conflicting trip, but yeah, that priority is pretty obvious. As far as sound levels go, let me switch you guys over to the in-camera mic from the perspective you guys are seeing. So that's the microphone from that camera. I don't think it has any processing done to it, so that looks very low. Yeah, that is way too low. That is way too low. Wow. That was quite low. Perhaps we should have done the firmware update. Should we have done the firmware update? But the firmware update wouldn't change anything about the Z height. Like that is like, ooh. I saw that it did press down the sensor quite hard against the bed when it did its initial leveling. So let's do the update. Let's try that again. Maybe we do have to run the calibration wizard for this to go well. But let's let's do it by the books. So, swipe left on the touchscreen. No, that's the other left, okay. Settings. Wi-Fi, am I connected to something? I'm connected to nothing. Now, what's my password? Oh God, I hope I get this right. Okay. Connected. Okay. So, next up, firmware update. Snapmaker improvements, add polish in Spanish. Always good to see that they're polishing there at the interface. Audio dead. Audio back? Are we back? Yeah. Man, the Rode Filmmaker kit, as good as it is, the fact that it runs on AA's and you have to like physically take them out in the most awkward way. You have to kind of peel them out because you can't just plop them out or else you bend the springs. You know what would make these infinitely better? If you could use the built-in micro USB port to recharge it. Like that would be amazing. That would make this thing so much better because you can always have it topped off. You just plug it in when you're not using it, and whenever you grab it, it's full. Otherwise, you always have batteries in there, and if you want a full pack, you have to do the swapperoo every time you use it. That gets annoying. So you try and get away with not swapping them out every time, and then you get audio dropouts. So, yeah. Oh, we're still on the camera mic? Well, here's the thing. Here's the thing. This thing was dead also. So you guys caught it just in time. Yeah, these camera mics are surprisingly good. Okay. Update now. Will I be at Formnext? No plans for Formnext yet, though I can do that pretty spontaneously. It's just I think a 1 charge or 2 charge drive there, so not a big deal. That can be a J trip if I want it to be. Finishing up controller firmware update. So yeah, the way the Snapmaker works is this is a phone. It's a full-on Android phone. I guess it has like cellular data and stuff deactivated, but it's a full phone. And it is plugged in through USB-C into the controller, which sits back here and has all the CAN connections attached to it. This USB-C both powers the phone but also acts as a USB link, like you would plug in your laptop into, you know, a 3D printer, an Ender, Prusa, whatever. So this thing essentially works as a host for this guy. At least that is how I understand it. So this runs, I don't know, Marlin, whatever firmware on the box, then transfers everything out to CAN, and then this thing does the like slow user interface stuff that doesn't need to be real time. And that way, of course, it has full access to a USB port on the controller, which it can use to either remote control it or update the firmware or do stuff like that. All right, I wonder why it went so deep. So, I mean, this is like way too deep. It's like, that's a good millimeter worth of. You can see that the print, the silk screen actually got dragged over. Wow. I wonder why that happened, because the height of the tool head is not set by the linear axis at all. It is just a sensor in the tool head, which we didn't change. I mean, this doesn't rotate enough to have this be so far up that the nozzle is enough. No. I don't know how that happened. Okay, update successful. Let's also do a bed calibration. So it's quieter than before, but it's not super quiet. It is not Prusa stealth level quiet. Are these buttons active? No, they're not. That's just doing like mesh bed leveling now, right? I guess one of the reasons why this wouldn't be as quiet as, you know, some of the other trinamic-based printers is that it's an all-metal frame. Like, you can hear how everything just resonates. That resonated pretty hard. Something went wrong. Well, I was able to hear that. It just crashed the nozzle into the bed. What happened there? What? Yeah, now there's another thing in here. Ooh, my Stream Deck is oscillating. I guess that speed is like resonance, straight up pure resonance. Hold on, I'm just gonna head over to the stream settings. Do I have strict mode? You know what? Let's use this fantastic opportunity to hand out some mod rights here. Here and who else do I know? There you go. I guess, yeah, some blue names there. Can I? Oh, hold on. I was so busy with chat. What happened there? Whoops! I should have paid attention. Check the machine. Okay, what's happening? What is happening? What's going on? What is going on here? Something went wrong. Well, I can tell. Did it do the same thing again, where it's crashed into the rear corner there? Retry. Show me what you got. Crash and drag. The y-axis is wrongly mounted. Oh. Yeah, well that's the problem. I can, okay. Masiliano, you are correct. You're correct. This is too far forward. Huh! How did nobody catch that? How did nobody catch that? But why did it drag the first time? Why does that cause it to drag that much? Okay, yeah, I mean that explains the dot in the back here, but okay. My bad. Let's try that again. I guess what I can do is just tilt it over to this side, because then we can lay it flat, and it does lay reasonably flat on that edge. And we can just unbolt these 8/16 screws and move the y-axis a bit further back, and we can use the Bosch Go for that. Different positions, so it's not on the magnets. Well, that could be something, but I wouldn't bet on that fixing the Z-height issue. We don't have to unplug anything. Just straight up move these back. Yeah, so that's one of the pros and one of the cons of having axes that have like all modular mounting holes. Like you can attach them however you want, but that doesn't mean it's going to work in whatever orientation you decide to attach them in. So now this is loose. Yeah, now I can just go ahead and slide this back by one hole. Is that the correct? Yeah, that feels better. Oh, okay. I can that does. I'm going to show you in a second. That does also explain the first layer. I see. Because there's a bit of a groove that these sit in, and the groove doesn't extend all the way out. Guess I should use the torque limiter here. The groove doesn't extend all the way out, so these were sitting on a bit of a lip at the front here. I'm going to show you once I've got these on, once we've got a better angle. So I'm just going to plop all these screws in lightly. There's a physical end stop for the y-axis. Yeah, there is, well, for the y-axis slide. There you go. Okay. I was wondering what these threaded holes were. There's 4 here and 4 there, but these are not used from this side. These are used from the other side for the Y and Z axis port multiplexers. Multiplexers? No, they're just multipliers. So yeah, as always, this base is overbuilt as always, being a complete die-cast part. As are many of the other parts in this printer, just completely custom extrusions. Built for volume, which I don't know if they have. If they have the amount of volume behind these printers to make that worthwhile. But that is not up to me to judge whether how they're making stuff makes sense, but apparently that's been the decision they came to. But of course, with like the linear axes, all sharing extrusion parts between 3, 4 different machines, you know, they do have some scaling effects there. All right. So what? I guess this perspective has it a bit better. What this bottom plate has is a groove that is kind of hard to see, but maybe you can see it at the edge here. Yeah, you can just barely see how this dips down into a groove right there. And that groove runs all the way along the side of these parts, but it doesn't extend all the way out the front. So with these being like one hole further out the front, so like basically here somewhere, they were sitting on that ledge. So that makes sense. And like the leveling wouldn't work. Okay, let's try again. So just to reiterate, that was not the printer's fault. That was just me slightly assembling it wrong. I'm going to take a quick correction tool and correct this bed surface. Okay, still slightly raised. But that should be functional. This bed is a stickered polycarbonate, so Build-Tech clone basically. There's a fresh one on the back. So if you want a totally fresh one that we can maybe ruin at a future date, we can use that backside, but the front for now is ready for testing. There's no lips or ledges stuff that could get caught. So let's try that again. Come on. USB, Samsung Space, nope. Samsung Space VESA adapter. Yeah, that's actually just reading from the USB drive onto the touchscreen, onto the phone that's built in here. So some of the move speeds have some very audible resonances. So when the Z-axis moved up slowly just a couple minutes ago, it was very loud. As is, this is a lot smoother than before. Like this is so much better. Hot and cooling fan definitely did that. Is now the loudest part. That is the part you hear the most, at least. I don't know if, as far as like decibels go, that is actually the loudest part now. But It is the one that stands out most clearly. It's definitely louder than a Prusa still. That's for sure. Or even a stock built Voron. But it is quieter than that guy in the background, which is the Ender3V2. That also has Trinamics drivers. I think it's got the same 2209s, or 2208s. I don't know, some of the low current ones. But it has much louder fans than this guy. So, happy middle ground. Where are we at with temperatures? 203 and 53. Okay. Crashed into the heater, better check. Eh. Looks all right. Oh. Z offset. So Z offset is at 0. Maybe we should raise that just a bit. Just a little bit. Just to be safe, so we don't actually break anything. Maybe just a tiny bit. Right. Because it's already sitting quite low here in the corner again, and yeah, it's looking kind of suspicious. And of course, we can always quickly drop this down once the print starts. Oh, the second I hit head back. Yeah, this is still like, oh wow. So supposedly this is plus 2 millimeters. How is that plus 2 millimeters? I can't even set the offset even further. So this, come on camera, this is, oh, did it, ah, now it's adapted, okay. So that's what I was saying with this thing. Like the controller is sitting in here where everything is plugged in, this has its own buffer. So we set the offset. Oh, this is crooked. What's up with that? Nope, I spoke too soon. This is way crooked. Like it's completely loose on this side. Well, it does stick, but on this side over here, it's not even extruding anything. It's just scratching the bed. So let's hit back and stop this, and let's try the calibration, the Z-axis mesh bed leveling, and see if that changes anything. Because like you can clearly see it like down the middle of the bed. This side looks okay, it's a bit too high actually, and this side doesn't even have any filament coming out. That is literally just ironing marks. Yeah, maybe I should let that cool off, but I do need to get this off for the leveling. Ah, Domenico, what did you miss? Well, we made a boo-boo. There we did a bit of a scratchy poo in the bed, and then we did a plungy poo up here. Yeah, so this bed is not in best shape anymore, but gotta make sacrifices. And that is a sacrifice that I'm willing to make. Okay, that's good enough. So let's try if this time we actually get the mesh bed leveling to complete. Nah, it's not there, and the edge swipe gestures don't work. So calibration, calibrate the bed. That is, I mean, that's all the calibration we get. Let's try. ASMR scratching. Well, we can make that happen if you're into it. It does like a very gradual probe cycle. Still moving down, but just very, very slowly. Then it does it again. How did I fix it? The problem was that these y-axis rails were too far forward. And as a result, they were kind of riding on this lip right here. And also the position was off. So how are they back? So I can click that, but it's just going to be another channel, right? But yeah, that was the fix. Yep. And the problem with the print I started just now was that it was quite okay, actually a bit too high up on this side, and then that side over there was just marring the bed. It did not. Paper leveling. Okay. That is too thick. It did not extrude anything on that side. So like the left-right level was completely off. Did they include a piece of paper somewhere? I think they actually, no, that's a card. Oh yeah, they do have the calibration card. The calibrated piece of plastic. Oh, that's actually now very high up. You can see how much distance they've got between the nozzle and the bed. So okay, that's catching. So one of the things maybe I should note about paper leveling is the catch point is going to feel different for it's going to feel different for every printer you use. So with this one, all the axes are very rigid. So the difference between this thing grabbing and not grabbing is not going to be a whole lot of up and down. If you have a printer that is less rigid, again, the Prusa is a machine that isn't that great in the mechanical stiffness department. And there it's more going to be like hey, you move down a tenth and it kind of starts to rub, then you move down another tenth and it kind of starts to grab a bit, and then you move down another tenth and it grabs a bit more. Here it's like you move down a tenth and it's the difference between, like this is completely loose, there is no resistance there at all. And then if you go down 500th, so yeah, still, maybe, yeah, with a bit of imagination, you can feel it right there. And then you go down 500th and it's completely locked up. And then if I go down another 500th, it does not move anymore. So just this point where it starts to grab, that should be a reference for any printer, whether it's rigid or not. You don't want it to actually pinch down hard. You just want it to where it starts to rub and it starts to grab, and you can start feeling a resistance. That is the point you should calibrate for. Cool. Let's try again. Let's try again. Let's make something wonderful. Space. Start. Same G-code, 17 hours. I'm not going to let that print. So Z-axis homes to the top, which makes sense. And the focus focuses to the middle of the frame, because that also makes sense. Homes to the top, then it moves down a bit, and it homes the X-axis to the minimum position, and then it homes the Y-axis to the maximum position. Which is interesting, there's a different home direction for every axis. And that was not a homing move, that was just a move to a known coordinate. So there, it's going to park, and I can actually see the sensor down here. I can see it just barely light up. I think it, I have to press down a bit on it. I thought I saw it light up a bit more a second ago. Yeah. Okay, last round of heating, hopefully. So the height should be calibrated, should be good on that front. Okay. Got an email about Streamlabs tips being broken. Well, I guess that's the nail in the. Oh, look at that bokeh. Nice. I guess that's the nail in the coffin for Streamlabs. I did look into Stream Elements a bit ago, which is supposed to be the non-evil alternative to Streamlabs. I will be switching to Stream Elements at some point, but they have so many features. They've got so much cool stuff you can do. I took a quick look at it. I was like, well, maybe I can just set up a tip site there. And I was like, oh, they've got that. They've got that. Ooh, that's useful. And then I was like, oh, I gotta start the stream because otherwise we're gonna be out of time. So yeah, I'm gonna be switching to Stream Elements quite soon. I just have to set everything up for that to work. So yeah, if Streamlabs is broken, sorry, but thank you for trying. Thank you for trying anyway. I appreciate it nonetheless, even if it didn't come through. This is looking good. And there's a bit of a. It does drag, it does smear, but this is looking like a proper first layer. Actually, I could move here. And then maybe if I do like the smart move and do that, move it like dead center on the table, like here, I can use that lever here. Look at that. Hope you guys don't get sick from the from the bouncing. But yeah, top camera also has physical zoom. I just can't get to it that easily. I do have a remote for that. I should just use the remote for that. Why am I not doing that? I've got one of those wireless Sony remotes that are heckin' expensive. I needed that for a project a while ago, a long while ago, but it still works on these cameras. But yeah, that's what the first layer looks like. And dare I say, that looks good. That looks what a first layer should look like. Nicely squeezed. That is a bit of support material. Nicely squeezed, even. That's good. Yeah, so I don't think we're going to be seeing much more. Is that the table with the camera jiggling? That is the... Oh, you can also see the slow back and forth. So there was the quick jiggle, which was the extension arm of the camera that the camera sits on, but you can also see that slow swaying, which is the entire truss system because it's just suspended on steel ropes, steel wires, ropes. That thing is now swaying back and forth. So you can if you look at the holes where these are at, yeah, you can or up here even. If you look at the edge here, it's just swaying back and forth, and that's going to settle in over a couple of minutes. Sorry about that. It is not the table. This table is very robust and rigid. But yeah, it's printing. It is printing. I don't know if it's printing faster. It feels like it's faster actually, but that should be something in the G code. They claim this printer does. Let me just pull that. Oh, and apparently that camera ran out of battery. Cool. I guess there's no point in even having that in here anymore. They claim, yeah, there's the Artisan, coming soon. It's not even out yet. 250. So $2,000 for the printer with the enclosure, because they can't legally sell it without the enclosure in Europe. They are claiming, I think somewhere, they're claiming 100 millimeters a second of printing, which always is a value you have to take with a grain of salt. All metal and well made, yeah, possibly a bit overbuilt, but A250, CNC carving. I thought it was like 100 millimeters a second that they were claiming for print speed, but yeah, of course that always depends on what sort of quality you want to get and yeah, whether the mechanics are up to it. Truss needs bungee dampers. Well, I guess I'm just going to attach some sand tainers to it, right? That's going to work. The problem is though with the truss is on a winch, so I can wind it up and down. If I need to work on it, I can wind it down to like here. It's going to smash the camera into the table. like that overhead camera, that's going to be in the table at that point, but I can wind it up and down. So having dampers on it is kind of or having it tied to the sides is kind of counterintuitive if I want to be able to lower it. But yeah, printer is much quieter now, for sure. It is at a level where I'd say it is not obnoxious anymore. I mean, the fan is noisy, but again, it is not as noisy as something like the Ender 3V2, which would be expected on a printer that costs literally 10 times as much. But of course, laser and CNC, this one does that, but the Ender does not. Yeah, cool. I guess I can actually start using this and start using it for projects and experiments, because before it was always just painful to even get out. All right. Upgrade successful. Upgrade successful, stream successful, except for like 1 or 2 times where the audio dropped out, but that is to be expected at this point, I guess. That's gonna be it. It's Saturday night, it is 10 p.m. I'm gonna head home. Thank you all for watching. Thank you all for being here. Thank you all for being actually pretty helpful this time in chat. And I will see you all in the next video. And I'm actually pushing out the next video on the main channel by a week. Just too much printing, took too long. Didn't get it done in time, and it would be way stressful to rush it. So yeah, that's getting pushed out by a week. I hope you guys don't mind, but yeah, we can do some streaming in the meantime. Have a good one. Where's my button to end this? There we go. Bye.